A compound contains 40.0% carbon, 6.7% hydrogen, and 53.3% oxygen. If the molar mass of the compound is 180, find the molecular formula. Solution. Before we proceed, if you are yet to subscribe to this channel, kindly do that and also click on the notification bell so you don't miss out on more videos like this. I'm going back to the question. We're being asked to calculate the molecular formula of the compound, and to determine the molecular formula of any compound, the empirical formula of the compound must be known. So that will be the first thing we'll be doing here. And to get the empirical formula of the compound here we have the compound to contain carbon, hydrogen, and oxygen. We need to know the simplest number of moles of each of the elements present in the compound, which should be also representing the number of atoms present in the compound. So to get this, we'll be using the formula of moles to be mass over molar mass, but here instead it will be atomic mass, since we are just dealing with just a single element. Another thing I would like you to notice that we'll be doing this simultaneously. This will be calculating that of carbon, hydrogen, and oxygen together in a tabular form instead of working it out separately. Also, here we are dealing with percentage. We do not know the mass, and in the formula for calculating moles we have mass divided by the atomic mass. So the mass will also be taken to be the exact value for the percentage. Since we are given percentage, then the whole compound will be 100%, and virtually it can be taken to be 100 grams. So now for carbon, which is 40.0%, if the whole of the compound is 100 grams, carbon, which is 40.0%, converting this to gram will then be 40.0 divided by 100 times 100 grams, which will also be equivalent to 40.0 grams. If we do the same thing for hydrogen, I have 6.7%, then this will also be 6.7 over 100 times 100 grams. Here also I have 6.7 grams. For oxygen, that will be 53. We have oxygen to be 53.3%, which will also be 53.3 divided by 100 times 100 grams, and this also gives 53.3 grams. So let's proceed. Now, stating the elements we have carbon, we have hydrogen, and we have oxygen. So what we want to do now is to calculate the simplest ratio in which each of them combines. So here we have that to be percentage composition by mass. This is 40.0, this is 6.7, and this is 53.3. The relative atomic mass for carbon, we have carbon is 12, hydrogen is 1, and oxygen is 16. And the mole of each of the elements will then be gotten by dividing the mass by the relative atomic mass. So for carbon here will be 40.0 divided by 12, hydrogen here 6.7 divided by 1, oxygen 53.3 divided by 16. So for carbon we have 3.33, for hydrogen we have 6.7, and for oxygen that is gotten to be 3.33 as well. So now after getting this to be the amount of each of the elements present, we'll then need to determine the simplest in which they can combine. That is, we do not want to have something like C subscript of 3.33, 6.7 and the likes. We need a whole value in the simplest form, as simple as possible. To get that, here we'll say divide by the smallest. I have the smallest here is 3.33, so I have 3.33 divided by 3.33, 6.7 divided by 3.33, 3.33 divided by 3.33. Here for carbon I have 1.0, for hydrogen I have 2.0, and for oxygen I have 1.0. Now this can then be taken to be the simplest ratio in which they combine. So we have 1:2:1, thus making the empirical formula of this compound to be equal to CH2O. Now I will explain how we come about this now. See, earlier I said the empirical formula shows the simplest number of moles of the element present in the compound. That is the simplest ratio in which each of the elements can combine. So now the simplest ratio here, now we have carbon to be 1, so we take that to be 1 atom present. So instead of having a subscript of 1, we will be neglecting that because it is insignificant. So we have C. For hydrogen here it is 2, so I have 2 as my subscript, and for oxygen here I have 1. So 1 is here also, which is insignificant in writing it, hence making this formula to be CH2O. This isn't the end of the solution to the question, because in the question we are being asked to calculate the molecular formula. That means we still have another part to this question. This is just the first part in attempting this question. So for the molecular formula aspect, the molecular formula is always a multiple of the empirical formula. That is, in the empirical formula we have this either once or twice or thrice and so on. So that is, if this is my empirical formula, the molecular formula can be twice of this, it can be thrice of this, and so on. Simply put, molecular formula consists a multiple of empirical formula of any given compound. And that multiple is what we need to determine. That is, how much of this is present in the molecular formula. Let's proceed. We've gotten the empirical formula to be CH2O. Now here we can calculate the mass of the empirical formula as well. Empirical formula mass is equal to the sum of the atomic mass of each of the elements present in the formula. So here we have 1 atom of carbon, and the atomic mass of carbon is 12, so that is 12, plus hydrogen is 1, the atomic mass of hydrogen is 1, and we have 2 atoms present, so we say 2 times 1, plus oxygen, which is 16, and this is 12 plus 2 plus 16, which is equivalent to 30. So the mass here is 30, then we can say 30 grams per mole. Now for the multiple, now if the empirical formula mass is 30 and the molecular mass is 180, then we need to know the number of times this will be present in the molecular mass. And so the number of times is what will be referred to as n, that is the whole number multiple, hence giving us a relationship to be molecular mass equals empirical formula mass times n. Do not forget I said earlier that the molecular formula is always a multiple of the empirical formula, where n here is referred to as the whole number multiple. To get n here, we just say, making n the subject, say n equals molecular mass divided by the empirical formula mass, which is equivalent to 180 grams per mole. From the equation, we have the molecular mass to be 180 divided by 30 grams per mole. That is the formula mass we got here, and this is equivalent to 6. That means we have a multiple of 6 of the empirical formula in the molecular formula. Since we've gotten n to be 6, then it will be easier for us to get the molecular formula of the compound. Then we can say molecular formula equals empirical formula into bracket of n. The empirical formula is CH2O, and we've gotten the whole number multiple, which is n, to be 6. So we have 6 here. To get the molecular formula, we will be multiplying each of the subscripts here by the multiple we have. So here I will have C, subscript of 1 times 6, I have 6. Then for hydrogen, which is H, I have 2 here as the subscript. 2 times 6, I have 12. And for oxygen, I have 1 as well. 1 times 6, I have 6. So the molecular formula of the compound is 6,6H12O6. So this simply shows that the molecular formula is a multiple of the empirical formula. And in any question that has to do with molecular formula, the first thing to do not forget, is to determine the empirical formula of the compound. And in cases in which you've been given the empirical formula, just go ahead finding the multiple, that is how much of the empirical formula is present in the molecular formula, for you to determine the formula of the compound. This will be the end, and this is also the final answer to the question. Once again, the molecular formula of the compound is 6,6H12O6. That will be all. Do not forget to subscribe and also click on the notification bell so as to be alerted as soon as new videos have been posted here. You can leave your comments in the comment section below. Thank you.